Hello and welcome to the section 10.1 lecture for Algebra 1 Part 2. Today we're going to be looking at adding and subtracting polynomials. We've got a couple definitions that are going to get us on our way as we work through this. The first one is a term, and we're going to think of this is kind of wrong for definitions, but a term is a building block of a polynomial. So it's not too good to have a word that you're going to define as part of your definition. But I'm going to kind of summarize the two definitions together, because a polynomial is just a collection of terms. So let's break that down a little bit. As with the rest of these. Okay, I'm going to use one example to kind of guide all of these definitions. Let's say that we have 3x to the third, that was supposed to be a 3, minus 4x squared, plus 3, let's go plus 3x, and minus 7. Okay? So that's kind of my driving example here. To break down the pieces that I have, each one of these blocks that involve a number, variable, and exponent, those are all terms. So all 4 of these are terms. And I even think of it as the sign as well. The sign is part of that term. So a term is a sign, what we call a number multiplied by a variable is called a coefficient. A variable and an exponent. So those 4 things come together to give us a single term, and when we have multiple of those, we have a polynomial. Now, not every term needs to have all 4 of these. In fact, this one doesn't have a variable or an exponent, this one doesn't have an exponent, but then these other ones have all of those. This one, you could say doesn't have a sign, but it's a plus sign, it's a positive 3. Standard form of a polynomial is as I've written this one here. And the important part is that exponents are in descending order. And so for this one, it goes x cubed, x squared, x to the first, and this is technically x to the 0 power. But because I've grouped these this way, it's really all of these 4 pieces added together. So because it's addition, I could move them all around, and I could rearrange this however I wanted. But this is the one way that's in standard form, because the exponents go 3, 2, kind of a ghost 1, any x is to the first power, and then no variable would be the variable raised to the 0 power. Okay. The degree of a polynomial is the highest exponent. So in this one, the degree would be 3. It would be a 3rd degree polynomial. We'll come up with a name for that in a second. The leading coefficient is the first number multiplied by the variable. And that requires it to be in standard form, because that's going to put the most important coefficient, this ends up being the most important coefficient, out in front. Okay, and that's why we call it the leading coefficient. It's the start of the polynomial. Okay, then we have some names, because we want to be able to talk to people about what different polynomials look like. And instead of just saying degree 1 polynomial or something like that, we have names for different degrees. If the degree is 0, that would be like, say, 5x to the 0. And that's the only term that can be there, because that's really just 5. Anything to the 0 power is automatically 1, and so this is just 5. And so that makes it a constant. There is no variable. If the highest exponent is 1, actually I'm not going to use 5 for that. Let's go with 4. And say we have 4x to the first power, and then let's throw on that plus 5. Anything to the first power, we usually don't write that. We would just say that's 4x plus 5. And that looks like slope-intercept form, right? mx plus b. And so it's a linear polynomial. If x is to the second power, I'm going to put all these on there, slowly building it up. We call that a quadratic. And if we have an x to the third power, we have something like this, we would call that a cubic. All right? And then based on number of terms, if it has one term, like this one does, it's not the only type that can only have one term. Any of these different degrees could have one term. We call it a monomial, as in 1 for mono and omial, or nomial from polynomial, meaning term. If it has 2 terms, binomial, like a bicycle, it's got 2 wheels. Binomial has 2 terms. Trinomial, tricycle has 3 wheels. Trinomial has 3 terms. If we get anything on either one of these with 4 or more, we can say a 4th degree. I got to spell degree right. We can say 4th degree, 5th degree, 10th degree. There are names for a lot of those, but I don't want to memorize a whole bunch. Okay, but we would call it a 4th degree polynomial. Say it had 4 terms, we would say that it has 4 terms. Okay, you might say whatever kind of polynomial with 4 terms. And again, with 5 or 6 or 7 or any growing number of terms, we just put the number of terms there. Okay, for most of these, I have, I didn't realize I left so many on there, but that's okay. For most of these, we're going to have names for them. Some of them will have to use just the number as the name. Okay? But we want to make sure that we start off by putting them all in standard form. That means I need to put all of my higher powers of x at the beginning. So I'm going to take this x cubed and move it in front. Sort of just switch places with these two. So I'm going to have x cubed minus 4x squared plus 3. Okay? And that right there has 3 terms. So we're going to call it a trinomial, and degree-wise, it has a highest exponent of 3. So it's a cubic trinomial, and we want to identify the leading coefficient. I'm just going to say LC for leading coefficient is 1. On the next one, I do need to switch the order again. We'll call it 15x cubed plus x. That has a highest term of, or highest exponent of 3, so it's cubic. It has 2 terms, so it's a binomial. And a leading coefficient of 15. This next one's already in standard form. Exponent of 2, exponent of 1, no variable. It is a quadratic because the highest exponent is 2. Okay, I got to spell that right. It's right there. You could have just read it. A quadratic. And there's 3 terms, so it's a trinomial with a leading coefficient of -7. The next one, anything with 1 term is automatically in standard form. This is a quadratic because of the squared. It's a monomial, there's only 1 term, with a leading coefficient of 8. The next one is in standard form. I have x and then no x. The highest power of x is 1, so it's linear. There's 2 terms, so it's a binomial with a leading coefficient of -12. The next one only has 1 term again. It's 18. There is no x, so it would be like x to the 0 power. And anything with a 0 power is constant. So this is a constant monomial. Anybody that tells you that they're talking about constant monomials, just look at them and say, so you're saying it's a number? Okay, it's a number with a leading coefficient of 18. It is. This one is just a number. It's just 18. But we can talk about it in very cryptic ways. The next one, I got a little combining like terms I should do here first, because those are both x cubes. So this would not be in standard form because I have things that will combine. It's 19x cubed plus 4x plus 3. And so that is a cubic because the highest power is 3. Trinomial because there's 3 terms. So cubic trinomial with a leading coefficient of 19. The next one here isn't in standard form yet. I'm going to switch these two. So I get -13x squared. And this is a big key here that, we always got told when we were in younger grades that if we have subtraction like this, when we have subtraction like this, we cannot commute. We can't switch things around. That was actually kind of a bad thing to say, because you just have to pull the negative with the number that's negative. Here my 4 is positive and my 13 is negative, so I can flip them around. Anyways, we have a quadratic trinomial with a leading coefficient of -13. And last but not least, we do need to switch this one around. It's going to be -42x squared plus 13. That makes it a quadratic binomial with a leading coefficient of -42. Okay, now let's get on to the main topic of today. That was a big one. We do want to be able to do that. But the main topic of today is adding and subtracting polynomials. There's one thing to think about when we add and subtract polynomials. Combine like terms. That's what we want to focus on, is combining like terms. Okay, so let's take a look at it. And I also want to write it in standard form because that's just going to be better. When it's addition, there's really not much to worry about. The parentheses don't really matter. So I'm going to look at, I have a 3x cubed. I have an x squared. I have a couple of x terms and a couple of number terms. I use different styles of underlining as I just look through it once to figure out what I'm going to have to do. And so I only have one squiggly underlined, so that's the only one to worry about there. I only have one kind of bracket underline, square underline. Then I have a -4 and a -3. Those combine to give me -7x's. And a +3 and a -5, which combine to give me -2 constants, or numbers. The next one is subtraction, and there is something that I have to do when I have that. But I am going to get rid of all my parentheses. I have a -x² plus 3x minus 4. I don't do anything with the first one, but with the second one, I distribute a negative. I have -2x², -x, and -1. Now I look at my different terms that I have, and everything gets to be combined with something else. -x² and -2x² is going to be -3x². 3x and -1x will be plus 2x, and -4 and +1 will be -3. Okay, just seeing how many we had here. We're getting up there in time, so I'm going to try to speed up a little bit. I've got -3x² plus x plus 8. I'm only rewriting this one because of the negative that I want to remember to distribute. -x², -8 is plus 8x, and -4. If you want to underline, you can. I'm going to save myself a little bit of time. -4x² plus 9x and plus 4. The next one's straight addition. I don't really need to worry about much. I can think of the parentheses not being there. I only have one x to the third power and one x to the second power. Now I have a -2x and a -6x, which make -8x. -1 and -2 make -3. That would be a cubic trinomial, or sorry, a cubic polynomial with 4 terms. Can't talk today. Not a good day to make a video. Next one's addition also, so I'll just combine like terms. I have a 4x² and a -5x². That's -1x². -2x and +1x is -1x. And -9 and -7 is -16. Don't make combining like terms much harder than it has to be. 2x minus 3 plus 7x², I need to distribute my negative. -3 plus 9x² plus 2x. I'm just switching the signs on all these. Okay, this one was an x². I have 7x² and 9x², that's going to be 16x². X-wise, I have 2 and 2, which is 4. Numbers-wise, I have -3 and -3, which is -6. All right. Make sure you write down any questions that you have over on the left. Otherwise, I hope you have a great day, and we will see you in class.